Okay, let's try now for more problems from 3D.2 number 5. Alright, let's try 5F. 5F is, where is it at? 5n plus 1. I didn't look at this ahead of time, I'm just doing this cold. 5n and 4 on the bottom. So somehow we're going to be able to pull the 5n plus 1 and 5n out from together. So let's break it down a little bit. So we know our rule: when you're adding exponents, that's the same thing as multiplying 5 to the n times 5 to the first power, right? Because when you put those two together, then you add the exponents. So that would get us, that's the same as 5n plus 1 minus 5n. So that's kind of cool because there's a 5n on both here and here. So now we could factor that out. 5n on the outside, that's not very good. And then the inside I have 5 to the first power, or just 5, minus 1. Oh, look at that. 5 minus 1 is the same as 4. So really, that's just going to be 5 to the n times 4 divided by 4. The 4's cross off. There we have 5 to the n. Alright, that wasn't too bad. Once you got that first step, that's the key. To see it goes from 5 to the n plus 1 is the same as 5 to the n times 5 to the first. Right? Remember your rules. When you're multiplying exponents with a common base, you add the powers. You add the exponents. Let's try the next one. So I'm just going to go right to G. Right? G is 5 to the n plus 1 minus 5 to the n, all divided by 5 to the n. So we can't just cross the 5 and the n's out at the beginning because of that minus sign. But we got to work with the n plus 1 again. So I think it's going to be the same kind of thing. It's going to be 5 to the n times 5 minus 5 to the n, all over 5 to the n. Now we can factor in the top of 5 to the n out. 5 to the n times 5 minus 1. It's like the opposite of the other problem, because now the 5 to the n's crossed off and all you have left is the 4. So there you have it.